I'm going to go ahead and get started. So how many of you are now in the room that did not just hear Eddie's talk? See, we should have put a prerequisite that they had to come to yours before they came to mine. So Eddie did a great job talking about work that he and I have done over the last 4 years, where a lot of the stuff that was done with FSI, with the financially, with the services, and how we test things both from a policy perspective all the way through to a deployment and then validating deployments to ensure that there's no man in the middle type attacks, things like that. One of the items that I'm going to talk about is a lot of that work is a prerequisite for us to be able to provision work in the cloud. The challenge that a lot of the customers that I work with today is, this is awesome that we'll have this capability, but they don't want to go off and provision a whole bunch of resources and then have it just sit there and wait for an application to be deployed. So how can I take the work that is going on in the common cloud controls and the financially, the FSI group, take those two, and then how do I do configuration management, do application delivery, and do all of that from top to bottom, and how do I do that in a repeatable fashion? Because that's really where we want to be able to get to as application owners. So a lot of the work that when we're talking about the projects that go to the infrastructure side really sits in the platform engineering teams, it sits in the operations teams. How does that relate to the software development teams that need to consume those resources? So this is, as you can see, this is absolutely me. So I was at a executive advisory board and they were doing headshots, and I did not like any of my headshots, so I ended up taking my headshot and I threw it into Midjourney and I said, hey, make me into a 40-year-old handsome man that has a nice tan, and this is what it got back. And I asked my wife, is this close enough? And she said, sure, go for it. So, but I usually joke around and I say this is my Tinder profile. But so today the things I'm going to talk about is when we talk about the individual components. So one of the questions that came up in the last session when we were talking about all this infrastructure is, this is like selling a bunch of individual features of a product without being able to have a story about the whole thing. And so when we talk about having all of these composable assets that we can use as Eric and Baron and I have talked with many customers, treating it like Lego blocks, and we can give you basically the Lego block book and say, if you need an airplane, you grab 10 reds, you grab 4 yellows, and you take those things, put them together, and at the end of the day, you follow the guidebook, and that's what you end up getting. So we'll talk a little bit about that, and then we'll talk about what an easy deployment looks like. We'll then talk about how chaos usually ensues around that. And then we'll talk about declarative versus imperative type of programming models and what that means to defining cloud control planes. So this slide is the same slide I've been using for over 20 years. And it amazes me that this slide has not changed. So we've changed some of the marketing terms, so software supply chain. Back in the early 90s, there was a gentleman by the name of Jack Greenfield who worked at Rational. I was working for a competitor called TogetherSoft. He and I were working with a lot of customers on J2EE projects, and we ended up coming up with the term software factories. We would go out and give talks about software factories, and all the developers raised up in arms saying, oh, you're trying to get rid of all the developers. You just want it to be like, no, we want consistency. We want reuse. Those are the things that you get inside of a software factory. And then we talk about software logistics. So how do I ship the software once I've got an artifact? And the components that we see across both sides of these are individual elements of the overall software development lifecycle. And many people will sometimes wear many hats. They may play different roles and do multiple of these different tasks. And at the same time, we, in very large organizations, will actually have teams that just own one of those blocks. So it's really important for us to be able to define what those standards look like. So this is what I see most of our customers really want to get to. So I am a huge Oreo fan. Anybody else here an Oreo fan? Anybody here like Oreos? Oh, there we go, fried. So when you have bought Oreos in the past, has anybody here ever opened up an Oreo and pulled the thing back and looked inside and gone, like, these are not the right Oreos? Like, oh, it's not the double stuff that I was looking for. These are the strawberry cream. We don't run into that situation. They are still good. So when we look at being able to build these repeatable processes, all of the work that is going into the projects that you've heard around common cloud controls and the financial infrastructure, those items allow us to be able to define the factory. What the work that we need to be able to do is we need to be able to take the factory and figure out what ingredients we need to put into that factory to be able to ensure that every time something that gets stamped out of that factory always looks the same. And if we're able to get those things to always look the same, so when I open up my Oreo box and I'm not seeing strawberry cream instead of double stuff, it makes it a lot easier for me to start thinking about how I ship it. So when I'm shipping those particular artifacts out into my production environments, we look at the different items. I had the opportunity in the mid-2000s to work for a company called RailLink. And RailLink is the E2E hub between all of the railroads. And I learned so much about shipping and logistics and multimodal and a lot of the things that we try to do, we don't realize how many things we can learn from other industries that we should be applying inside of our own. I can't go ahead and say, I'm just going to go build a container and I'm going to make it whatever size I want. Well, imagine that's what we do inside of our companies where we go in and say, oh, here you go. Let me just go ahead and give you a login into the AWS Cloud Console. Click, oh, look, I can create 5 of these, and I can create 2 of these, and woohoo, now also my cloud bill is 8 times what I thought it was going to be. So what we do is we define standards for a container because what happens if I didn't define that particular standard? All of a sudden I need to go through a tunnel, and all of a sudden it's too wide. I'm going to take out the tunnel. I could take out the entire train. I could have hazardous materials that are attached to the train of the cargo that it not even know that it's on that train, and now I've got a hazardous spill. So knowing that these standards exist allows us to then compose all of those reusable assets into a manifest. Again, something else that I've learned that we have a tendency to reinvent things. Like, I'll never forget the first time somebody came along and was telling me about this awesome thing called Kubernetes. And, oh, by the way, here's a Kubernetes manifest. And I said, you do know why it's called a manifest? Yeah, because it's cool. Because it's a manifest. I said, no, this comes from the shipping industry. I said, I have a manifest because I'm going to declare what is on the boat. I'm supposed to have 380 containers on the boat. If all of a sudden we go through and we count and we find 400 containers on the boat, I've got 10 containers unaccountable. Oh, that's why we have a manifest. Yes, you are declaring what you want at the end of the day. So when we start to think about these composable assets and we start to think about what sort of manifest do we want, we need to look at what the process looks like sort of end-to-end in a software development lifecycle. So this is a high-level view. I'm the global field CTO at GitLab, and I have to have my executive speak, and I have to have my developer speak. And when I'm talking to an executive, this is the slide that I give them. I'm like, this is sort of what your teams do, and get a lot of head nodding. So we got a schedule change, we're implementing change, and then we're delivering change. Yep, that's what our teams do. And then we talk about building change plans, doing change reviews, having a change request. In GitHub, that's called a pull request. In GitLab, that's called a merge request. And then out of those, we have change events. That ends up leading into those events, trigger automations. Those automations are going to be my pipeline. So I'm going to have security reviews. I'm going to have everything else based off of that one single change event. And then at the end of the day, what you're hoping is in the back of the database, you've got change records that are going to be stored there. So you can do your auditing, you can do your compliance, you can do everything else. So you've got change records. And I'm like, So basically what you are is you're just the office of change. And they have to sit back and they're kind of like, yeah, that doesn't sound as exciting as the DevOps transformation, mutualization, whatever acronym you want to give group. Nope, you're just in charge of managing change. So if we actually apply that to what we want to create is we've got agile planning tools, our distributed version control, we have release planning tools, then we have an orchestration engine that has automation, and then there's some database on the back end. And all of these things are all stitched together with APIs in front of all of them, and then we sort of do whatever we want with all of those. The challenge with all this is when we want to build composable, reusable assets is how do we connect all these tools today? What do we use? So if we were to use these, we use these wonderful things. We use webhooks. Webhooks are amazing technology because I can define them and they have no guaranteed delivery. They have no retries, fire and forget. So what I end up with is I end up with this huge dumpster fire of messages that go all throughout all of my different tooling, and we expect to, at the end of the day, have secure, compliant, composable, reusable assets that we can guarantee when we deliver, that we know that the applications that sit on top of it are secure, the software supply chain is secure. You can't do that with these kinds of things. So this leads us to, well, if I'm not using webhooks to connect all of these things to be able to do my delivery, what does that look like? Well, we have to have a discussion about imperative versus declarative deployments. So when I talk about imperative, we're talking about building a set of steps. Those steps have to be reusable. So I don't want to have everybody have to build their own set of steps. So I've got to have templates. I've got to have those templates then that can be shared. And a lot of companies that we work with are using inner sourcing. They use other models to be able to build these best practices for these templates. And then when we declare things, it's creating that manifest. This is what I want, and this is what I want it to look like when I deploy it. So these two things should map exactly one for one. So if we look at a traditional application definition, so we've got our firewall, we've got a load balancer, you've got your middleware components, you've got a database, eventing, API gateway, application, front-end web UI, back-end API. All these resources, remember we just talked about all these things when we go through the software development lifecycle. Think about things that sit behind all of these for me to be able to deploy this one single application. So a lot of times we'll talk about reusing a firewall config or reusing a load balancer, and we're redeploying into the same environment. But for a lot of customers that I'm talking to today, they want to get to the point that they can make these environments ephemeral. They want to tear them down and build them back up. And that's really where the public cloud is very valuable. The way that we've treated traditional internal infrastructure, like I could not imagine me taking 100 years worth of data in a mainframe and saying, hey, let's just go ahead and destroy all of that data and then rebuild it from a backup, and let's do it in a deployment window that has 30 minutes. It's not going to happen. So these new infrastructures allows us to be able to think about our models a little bit differently. So when we think about doing a deployment, it's not as simple as just being able to do a full declarative model. Like, I love people that come in and they'll talk about Argo CD, they'll talk about Flux, they'll talk about defining a Kubernetes manifest, and they'll deploy their pods and everything in their Kubernetes environment, and they'll do a rolling or a blue-green or a canary, and they'll do those things. And then I'll start to say, well, what about the context that needs to be changed for the firewall? What about the virtual IP addresses that just need to be mapped to a new service that just got deployed? What about the database changes that needed to happen? Did you do a backup and then did you do a change so that way, like, what about all those other things that needed to happen? And they're like, yeah, you know, somebody else does that. I'm just responsible for deploying the application. Well, when we think about doing these kinds of deployments, we think about all the different steps that we need to go through. So in most of our customers, they go into their change management tool, they open up a ticket, that ticket gets assigned to somebody, they go run some scripts, they go do some things in the back end. Developers will create their branch, they'll go make their changes, they go ahead and create a new artifact, that artifact is then published, and then they create another ticket to go ahead and say deploy this particular artifact. That's a really long process. And for us to be able to use and reuse the compliant infrastructure that Eddie was talking about earlier, we need to get to a point that we can automate a lot of that. So a lot of the things from a security perspective, everything that we're trying to do with the projects that Eddie spoke about is really creating guardrails. What we want to do is we want to know that what is being deployed as those composable artifacts is really something that I can trust. And then I can verify based on the work that's happened before it. Now, when we talk about going through and doing a production release, so if we're doing a dev test and then we're rolling it out, one of the things that just amazes me is everything that we just did for dev test, we redo all over again for production. One of the things I actually joked around with somebody, I said, if you're deploying into Kubernetes, I'm like, and you've just deployed your entire new application, you just deployed it into dev test, why don't you just tear down prod and just make dev test the new prod? I'm like, oh. Well, because that's not the way we do it. I'm like, well, you could. Now what I do is I just rotate between dev test and prod, and I just make them, that's my blue-green. I can stand up a new one. Now that one's now dev test. The other one's now production. You start thinking about different ways that we could be doing these production releases, and that imperative versus declarative model becomes simpler and simpler the way that we're the more and more that we're able to build those composable, reusable assets. So it has always amazed me when I've thought about how difficult it is for us to get a very simple change into production inside of a lot of the customers I work with. When we have people like the US Post Office can get me a postcard letting me know that my dog needs its vet checkup, and it comes to my door, and I may have moved 3 times in that last year, and it still finds me. It gets to my house. But I can't figure out how to get an artifact that I've defined as good for production and release that easily into a production environment. So the way that we need to think about this is if I've got already well-known paths for me to be able to get an artifact into production, then I should be able to take a combination of an imperative deployment and a declarative deployment and piecemeal them together. So let's talk about imperative deployments. So when I look at this, there are some things that you can do with Git. And I used to work at GitHub. I'm now at GitLab. And one of the things that was very interesting is I would joke with people here, how many people here use Git on a day in and day out basis? Okay. So I usually joke with people because I'm like, what most people know how to do is they know how to do a clone, right? They know how to create a branch. They know how to do a commit. And they know how to do a push. And then once we go beyond that, sort of don't know. If I ask you how to go ahead and do a cherry pick, how to do that from the command line, or I ask you to do a cherry pick with a stash, or how to be able to change the head of a current remote so that way you can push into a different branch, or how to undo a task without having to go ahead and just delete and then restart the repository. Those kinds of things, it's like, well, hold on, I gotta go get the book. Let me go open up the book, then I can walk through the steps. What you don't realize is when you open up the book, you start going through the steps. If you don't know the process of the steps that you need to go through, you can actually make yourself in a worse position than you're in today. So when we get to really understand how Git works, we can do some really interesting things. So how many people here have ever created a new remote? Okay, create a new remote for your repository. And this is not so you can take your internal work and then set a remote so you can send it to some private location in some other third world country. This is all for business purposes. We're all in a safe space here. So if we think about having our project structure, so all of the work that we're doing with common cloud controls and our financially compliant infrastructure, all of those different things that we have, imagine being able to have them listed inside of a directory structure like this. So now I have all of my individual cloud resources defined in a taxonomy. I don't have to necessarily have them by cloud provider. I could just say, hey, I need a VM, or I need a relational database, or and I can have not only the provisioning scripts, but I could also have all of the tests And I'm definitely going to be looking very closely at private tier because this plays really well into this model. And now when I want to go ahead and attach this to a project, what a lot of people that I do is what they'll do is they'll take a bunch of the stuff in here, and what they'll do is they'll say, okay, well, I need AWS resources. So usually that'll be the platform engineering team. They'll go off and they'll go provision the resources on my behalf. Well, then how do you know which resources at what point in time are actually associated with the application that you just deployed? So there's a way to be able to do this. This is really cool. So what you can do, I have to get my glasses on here. So there's a number of different ways to do this, but what you're going to do is you're going to clone your project. And when you clone that project, you go into the directory, and then what you can do is you can add a remote to a different Git project. So now I've got two remotes. So I've got the remote that my actual application code is in, and then I'm mapping a remote to another project that has all of my infrastructure that I need. Then what I'm going to do is I'm going to create a checkout into a new branch. And one of the things that I always recommend is you've got a good naming convention. So here I've got infrastructure/merge EC2 into my project. And what I'm going to do is I'm going to fetch that particular project. So now I'm asking the two repositories to have a little conversation because these two code bases are not alike. So I'm asking it to say, I'm prepping you that I'm going to bring something in here that you're not ready for. And then what I'm going to do is I'm going to do a merge-s, no commit, and I'm going to bring in to the EC2 main branch, and I'm going to bring that in. I'm going to do a -- allow unrelated histories. So now I'm saying I don't need these two streams to be brought together by the SHAs and asking them to align them. I'm basically letting it force, it's almost like a force push into the other project, say, I need this code in this project. Then I'm going to do a git read tree, and I'm going to do a -- prefix, and I put in here, you can call it whatever you want. So I did .aws/ec2. What that prefix does is it's going to create a directory inside of this project called .aws/ec2, and then I'm going to map that folder upstream to the EC2 main that I'm bringing in. Now, imagine if you have tags. So let's say I've got different versions of EC2 that I need to map to this project. So I could have a version that we need that is 2 years old, because for compliance reasons, that's what I need to be able to map. You could map to a tag. I don't have to map to a branch. You could map to a specific SHA if you wanted to. So you could bring in just an independent change that you can then map to this project. Now when you do a commit, that .aws/ec2 folder is going to be brought in, and the history that is in line with that particular SHA, that particular tag, that particular branch is automatically going to be brought into your project. Now, I now have my specific infrastructure to a specific release target to be able to map. So I could have my automation scripts, my provisioning scripts, everything else that goes along with that could exist in that EC2 folder. So now when I want to go ahead and run a CI job, I'm automatically bringing that in, and all I need to do is just import that into a CI workflow. So I have now brought together two disparate Git repositories to make it one Git repository, and now I can automate that work across. So I've declared what I want the infrastructure to look like in the EC2 project, and I'm doing an imperative model using a workflow engine to go ahead and add that new step into my project. Does that make sense? Usually I get to this point and some people's heads start to explode. Okay. So the reason we want to do this is, again, when I look at different things about how we're able to reuse elements in the real world, is it's amazing to me how Amazon is able to deliver something to my door in sometimes that evening, sometimes next day, but it's always within 2 days. And I know this because When I get home from my business trips, there's always about 5 packages that my wife has ordered that week. So when I go ahead and look at how efficiently they are at the logistics process, why are they able to do that? Well, because they've learned that if they can take warehouses and put it close enough to larger geographic regions, they can start to fill those warehouses with commonly purchased items, doing predictive analytics to be able to say, people in this area normally buy things. So now where I live in South Carolina, I live near the beach. Well, they're going to stock the warehouse with things that people would normally need if they go to the beach. So sunscreen, I can get that evening. If I'm in somewhere in Montana, they probably keep warm jackets in the warehouse, because those are the things that people would normally buy. So being able to have these things that we normally would keep nearby for our projects allows us to be able to ship things much faster. Instead, what we end up doing is we end up building these really complex workflows, and this is actually the GitLab itself, the GitLab project, open source project. And so when you look at all the different tasks, this is just the flow of each one of the jobs that are grouped together. And there's another view that you can see the dependencies and all the dependencies across all of the projects. And sometimes it gets out of control. We need to refactor things. We need to keep things up to date. Those kinds of things we then need to map back to our declarative model. So when we're mapping these two things together, you can see that we've got an opportunity where some things can go wrong. So what if I could get rid of the imperative model altogether? What if I didn't need a workflow? What if I could just say, hey, by the way, change is coming, and I just release the change? So that takes us to, this should be the declarative model, declarative deployments. So there is a CNCF project called OAM. And I've been playing around with this a lot for different customers, because if I can take all of the Terraform scripts, Ansible scripts, Pulumi scripts, whatever I need, and I can contain them in a single file, and that file can also have all of my policies that I need to map around those. And then I can have something like private tier that once everything's been deployed as a stack, and I can then iterate over that stack and validate that, yes, what I expected to be deployed got deployed. I've now met things like SLSA 3 standards. I'm able to ensure that I don't have places where somebody could go ahead and hack me. One of the sample projects that's doing this is called KubeVela. And KubeVela kind of sits in that area of control plane space. So if we look at a sample model for this, here what we have is a Kubernetes CRD. And what we're able to do is we define a kind, and there's a CRD kind called application. And what I can do is I can add in the components that I want. So a lot of times in an imperative model, we can't even do release orchestration, because I've got to wait for project A to be deployed until project B gets deployed, and then project C gets deployed, and all these things all depend on one another. And if any one of those doesn't get deployed, heaven forbid should I have to do a rollback strategy and go back to a previous version. This allows me to treat everything as a single resource, and it will do a blue-green type deployment automatically for me. So when I go through, and not only do I have each one of the different components with the resources that are associated with it, I can also map infrastructure resources that I need for each individual component. So I can have a reverse proxy. I can have a context for a WAF or for a load balancer, or whatever I may need. I can map those things together. And then down at the bottom of this file, you'll see that I can have things around what sort of policies do I need to apply to this. So I've got PCI DSS, or I have something else where maybe I pull in some sort of OPA, open policy agent, something else to be able to validate that some of the infrastructure got deployed, but I could absolutely use something like private tier to be able to do that validation as well. So when you want to go ahead and run this, the great thing about it is you can run this command, and what you do is you're using the traditional kubectl command. So nobody needs to learn how to build a custom job, or they need to do something else. I just do basically a kubectl apply for that resource. But if I wanted to go ahead and I wanted to enable Terraform, there are plugin modules that you would apply. So here, when I do a Vela def init S3, this is now telling me that inside my project, I've got an S3 module that I need to bring in as a provider, tell it that it's for AWS, and then it will automatically go ahead and deploy. And the -- local is, I would give it the path to that particular resource that needs to be added. And then I can do a kubectl apply, and that will automatically deploy the resource that was defined in that resource definition. So this allows us to be able to think about that original diagram a little bit differently. So now if I'm doing it this way, I have a known state based on this config file, and I can look at the state that's actually in the application. And the difference between the two of those is what we would normally discuss as drift. So if I've got drift, you might want to figure out, like, is that drift intentional? Did somebody log in to the console and make changes without somebody knowing? Because you might want to fail on that because you don't know what resources they have made configured, and you may be overriding something that's been set manually. So now you can mix and match both an imperative and a declarative model together using that compliant infrastructure in a way that now lets us be able to look at those different components at the top. And when we talk about orchestration, CI/CD, automation, not only are we going up and down between the project of being able to map different resources, I can also move completely automation from left to right. Most of the times, the only thing that we do is we only ever think about a deployment of resources from left to right. Because what we're interested in doing is it's always a forward change. Well, if I've got, this is a conversation I have with security people all the time, is developers normally don't define a underlying Docker image. It's usually a Docker image that the security team, the platform engineering team, they build, and then they give that Docker image to somebody to be able to go build their file layers on top of it. Well, if I have a CVE to an underlying dependency that the platform engineering team introduced, but I'm the application developer and my application is just deployed on top of it, whose responsibility is it for being able to do a remediation? Well, that means I've got to take an application that's currently sitting in production and I've got to move from right to left because now I've got a policy that I'm out of policy in production. So now I need to do a remediation plan, which means I got to define all my requirements for unloading all of those resources before I can make the changes, redeploy the application, redo my testing, and then deploy back into production. So the whole goal of this is when I mix and match the common cloud controls, the FSI for infrastructure, we take that as our reusable assets underneath the hood, and then I apply a combination of imperative and declarative workflows on top of that. It allows me to be able to build a stack from top to bottom that makes it much easier for us to ensure that what's being deployed is compliant as itself. So with that, I will stop and ask if there's any questions. No questions. Any comments? Anybody doing this today? Yeah.
The beginning, you asked those questions from the beginning. Obviously, everybody's super scared, right? And then you proceeded to show that slide that had your magical Git annotations. Could you bring that one back?
Yeah, sure. So the first thing that you're going to do is we're cloning the repository to our local file system, right? Now I got to change directories into that particular project. So now I am sitting inside the project where the .git folder resides. So this is my application code. This allows me to separate the application code from my deployment code. So for a lot of companies, their platform engineers are responsible for the Terraform scripts, the Pulumi scripts, the Ansible scripts. All of those things sit somewhere else in the infrastructure. The challenge that a lot of companies have is mapping what version of the infrastructure is deployed to map to which version of the application that is currently in a change state. Okay? So what I can do is I can now add a remote. So I'm inside that directory. All I'm going to do is just add a new remote. And I'm going to point to a project that is not my application project. It's to where that infrastructure code lives. So now, once I have those two things, I now have a remote that I can now do a git pull out of that repository. Can't do a git pull yet because these are on two completely divergent SHAs. So one of the Git 101s that I would normally do is, one of the things that's really crazy is once you have a SHA, you can actually copy that project, move somewhere else, and as long as you have that same SHA, and that change maps back to a SHA in another project, I can actually merge those two things back together just by doing a copy and paste without actually using any Git commands. It's crazy because Git understands that those two SHAs are related, and I can build an entire tree off of the other one.
Can you do something similar with a Git submodule?
You can use submodules. A lot of people don't like submodules because then I need more Git commands. And then when I want to do CI, if I'm doing CI, CI has to be submodule quote unquote aware. And that can cause a whole other set of issues. But you can absolutely use submodules for this.
Well, would the difference be, am I correct in thinking that you would use a submodule for segmented development, and this approach that you have on the screen is to merge development trees into one?
So that would be a scenario that I could see. The other thing is if you need to map a specific set of resources to a current version that you are going to build. So I've seen customers use this a lot when they need to go do a build for deployment. So they want to create that one single artifact that has all their infrastructure resources and their deployment resources as a set of archives. They'll do this as part of their, they won't necessarily do the merge or the commit at the end. They'll just bring everything together so they know that they have a mapping between the two. But when you're using a submodule, the challenge you have with a submodule is I bring in all of history. Where this one, I'm only bringing a subset of that history. So I'm mapping it to a specific instance in time, rather than mapping it to an entire project. Because then I could, if I'm doing a build in a submodule, who knows which version I may have mapped my build to, unless I go back and actually look at the build data. Okay, yes?
Just a follow-up question. So like you have AWS and EC2 as like a module, the separate one that you're kind of blending into the world one, right?
Yep. So
If I were to be using other cloud services, other cloud providers, the idea that you would use that remote for each of them?
yes. So let's say I've got EC2 in AWS, and let's say I'm using Cloud Functions in GCP, and let's say I'm using Azure RDS or whatever they call their database. So if I have all three of those, I would have a .aws folder, a .gcp folder, and a .azure folder, and then the resources would be in each one of those, and I can link all those together, so when I've got my application and I want to think about it as a single artifact, everything is together as in one single place. Does that help? You need to have good naming conventions. So this is my oldest daughter. She went to South Carolina University. She was a computer science major. Their professors did not really understand best practices with Git. So what they did is they told the students to go create a branch. Well, the students didn't think that that meant every student create a branch. That meant one student created a branch and everybody collaborated on one branch. Well, needless to say, they ended up in a merge state that was very ugly. And my daughter is, I'll never forget her sitting up in our bonus room in tears going, "Dad, this is due at midnight and nothing works and it's all mixed together." And I'm like, hold on. And then next thing you know, I'm running a bunch of Git magic in the background, running stuff, and all of a sudden we get it back into a good state. And I'm like, okay, so here I've got these stashes. We've got to put these things back in. I cherry picked a bunch of stuff out, and we got everything back in alignment. And then once we had it back in alignment, I pushed it back in, and she got a nastygram from the professor because the professor could see the history. And because of the work that I did, I had to rewrite history multiple times to get the code back into a segmented state. So they were asking my daughter where she learned how to run all of these commands to be able to get back into a good state. And she did not like telling the professor that at the time that I worked at GitHub. Because then the next thing that she immediately became the Git expert inside of her class. But yeah, if you don't have good naming conventions, good branching strategies, things like that already, that is phase one. You've got to get to that point. Once you get to that point, then you can start to do some of the more advanced Git techniques like this on the back end, because people understand that, oh, this is an infrastructure mapping, not a development, this is not a feature branch, it's not a hotfix branch, it's something that's coming from the infrastructure side, so I don't want to muddy the waters between those two things. And that folder is now just for AWS assets coming from the infrastructure team. Okay? Great. Well, thank you all very much.